Okay, Hanoka, sit down. So we're on, what are we on now? Series 6?
Yeah.
Okay, we have to be getting better by now. Okay, again, I don't have any, I don't know, did somebody stole my worksheets? That had to have been. Series 6. Number 2. Find the interval of convergence. Okay, again, you are going to get this on the test. How do you find interval of convergence again? The absolute value of r is less than 1. So whatever the common ratio is, you just put it in there, you get 1 point. So what's the common ratio for number 2? 2x over x minus 1. And then all you gotta do is solve this inequality. Now there's plenty of ways of doing it. Just do it mathematically correct and no one gets hurt. So what do you want to do? You want to put gorilla in the middle like this, and then put negative banana and banana there. Why not? Well, since we have so much time today, why don't I just show you? Because most people are going to do this. Now, how do you solve this? Multiply through by x minus 1? No, because you do that, that's a fatal error. Because x minus 1 is sometimes positive, sometimes negative. So you only, when you work with inequalities, if you want to keep the inequality signs the same, you have to make sure that it's positive. So you can't do that. So what do? You got to split it up like this. And, because that's what that means, right? So what you have to do is you have to solve this inequality, you have to solve that inequality, and then what does and mean again? Intersection. Then you find the intersection of the two. So let's go ahead. How do you solve this? Multiply both sides by x minus 1. No, you're just going to lose all the points you just got right there. You make one side 0, so add 1 to both sides. Like this. See? See how I do it? Since you got to make the least common denominator. X minus 1, 3x minus 1 greater than 0. Okay, let's do this one too. Make one side 0. So subtract 1. Oh, that's 0, fool. And so if you make the least common denominator, what's it going to be? X plus 1? Did I do that correctly? Yeah. Of course, I'm the teacher. Okay, now, probably what you want to do is graph both of these on the same number line so you can see. Okay, so here's 1. Here's 1/3. How do I know it's going to be like that and like that? How do I know it's going to be plus minus plus? Because duh, I've done dozens of these over this year, right? That's what you should be thinking. Anyway, just plug in numbers. Now what about this one? Here's negative 1 to 1, and how do I know it's going to be in between like that? Again, plus minus plus. So now, and means intersection. Now look at these two graphs. Where do they overlap? Where is the overlap between them? Between negative 1 and 1/3. So I'm guessing your problem is you guys forgot how to solve inequalities. Yeah. Okay, now there is a faster way, but then you gotta know stuff. Like, if I were doing this, I would not do it this way. But this is the way you would do it if you don't know anything. I guess if you don't know anything, you couldn't even do it. This is what I would do. First of all, I would split it up into 2 absolute values like this. And then I would do this. Can I multiply both sides by absolute value of x minus 1?
Yes.
Yes, because absolute value of x minus 1 is positive. That's why you have the absolute value there. And then remember I taught you guys how to solve this back in the 2nd quarter? Remember the math team secret? Square both sides. And then you make, it's like you've never seen this before. What's going to happen when you guys go to BC? Pain, that's what's going to happen. Make one side 0, and then you have a difference of squares. See, this is like a squared minus b squared. How do you factor a squared minus b squared? A plus B times A minus B. What is A plus B? If this is A and this is B, what is A? Here, I'll write it for you. No, too late. A squared minus B squared equals A plus B times A minus B. Come on, even the algebra 1A people know that. Okay, so this is A and this is B. What is A plus B? 3x minus 1. And what is A minus B? X plus 1. And then to solve this, you make a number line. You got negative 1 and 1/3. No, it's plus minus plus because the leading coefficient is positive. And we want less than 0, so we shade in the minus. And lo and behold, it's the same answer. Now, I don't care how you solve it, you gotta solve it somehow. You gotta figure out a way to solve it. Yeah, we're in trouble on that one, yeah. Oh boy. 3A and B, 3A. Oh, 3. That looks like the one we did yesterday. Okay, n equal 1 to infinity, 1 over 3n, what is it? Minus 1 times 3n plus 4, is that correct? Plus 2, is that correct? Okay, now, how many of you did the partial fractions things from yesterday? Oh, very good. But you don't have to do that. You can do this any way you want. But on the test, I'm going to tell you what to use. Like I'm going to tell you, decompose it into partial fractions or look at the limit of the sequence of partial sums. Which way do you want to do it?
The limit.
The limit of sequence of partial sums. Okay, let's write out the first few terms. Plug in 1. So you get 1 over 2 times 5, that's 1/10, plus 1 over 5 times 8, plus 1 over 8 times 11, plus 1 over 11 times 14, plus dot dot dot. Okay, what's the first partial sum? Add up the first number. 110. Add up the first two numbers. 180. Add the first three numbers. These are the partial sums. 12 over 88, which can be reduced to 3/22. And then add up the first four terms. That's going to be, don't tell me, 22 over 154, which can be reduced. What did I just say? That's not right, yeah, wait, 27, yeah? Oh, it is 22. 22 over 154, how does that reduce? Okay, wait, I'm not doing it. Okay, 17. Mr. Park, I don't see a pattern. Yes, you do. Well, maybe instead of 1A, you should change it to 2/16. Because no, there's a pattern. And instead of 1/7, you should change that to 4/28 so that it fits the pattern. Now it's easy. This is the sequence of partial sums. What's the explicit formula? How do you generate 1, 2, 3, 4? What about 10, 16, 22 to 28? What's the common difference? 6n and then adjust. Plus 4. So what's the limit of the sequence? 1, 6. Woo. If the degree of the top and the bottom are the same, the coefficients, right? So that's how you do it, looking at the limit of the sequence of partial sums. Okay, there's no doubt about it. You're going to have at least one of these on the test. Okay, and then D. Okay, if you miss D, just go to your room right now. Go to your room. You're grounded this weekend. Okay, sigma n equals something to infinity. 1 or is that what's throwing off? The -1. And then 2 times 3/5 to the n. What kind of series is this when you have a number to the n power? This is geometric. What's the common ratio? 3/5, the number in the parentheses. Is the absolute value of that less than 1? Yeah, so in infinite geometric series, what's the formula? First term over 1 minus r. This is the easiest thing you got on this test, sister. So how do I figure out what the first term is? You plug in this number. This is the first number you plug in. If I plug in -1 for n, you're going to get 2 times 5/3. 10/3. And then what's the common ratio? The number in the parentheses. And then, come on. You wish you get a problem like that. You guys gotta recognize geometric series. That's, come on. Come on. Come on. Okay, next, 7b. Here we go. You guys never liked the binomial theorem? Well, let's just do number 7. 1 plus x squared to the -3. Okay, well this, you could actually do long division if you wanted to. Right? Because doesn't this mean 1 over 1 plus x squared cubed? Because those of you just who really hate the binomial theorem, and then you can go 1 divided, then you just gotta expand this, right? How do you expand a plus b cubed? Use the binomial theorem. So 1 cubed plus 3x squared plus 3x to the 4th plus x to the 6th, right? 1, 3, 3, 1. And then you can do long division. There's nothing wrong with that. But I'm telling you right now, people, on the test, I am going to force you to use the binomial theorem, because I'm going to make that exponent a fraction, and then there's no choice. So why don't we practice using the binomial theorem now? So what's the first term? A to the n plus n. The power of a goes down by 1, the power of b goes up by 1. N minus 1 over 2 factorial. The power of a goes down by 1, the power of b goes up by 1. N, no, not yet. N minus 1, n minus 2, all over 3 factorial. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem. Okay, let's write out the terms. Let's simplify. 1 minus 3x squared plus 12 divided by 2, 6, x to the 4. 3 negatives minus, so the 3 cancels out, 20 divided by 10, x to the 6 plus dot dot dot. Okay, now it says, well, I don't even know what it says. Find the 1000th term. Well, just keep writing until you get there. Find the 100th term. Oh yeah, just keep writing until you get there. No, you look for a pattern. In fact, maybe on the test I ask you to write it in sigma notation because it's the same thing, right? Why don't we do that then? N equal 1 to infinity. Now maybe you probably should write that as an x to the 0 so you can follow the pattern. Okay, the first thing you notice, it goes positive, negative, positive, negative. How do you make it alternate? Negative 1 to the n or n plus 1? N plus 1 because you want the first one to be positive. Okay, now the numbers. 1, 3, 6, 10. Hey, you somebody, yeah? The triangular numbers. You guys supposed to know the formula already. There you go. If you don't know it, suffer. If you don't know it, look at the differences and then look at the differences and then solve the 3 equations, 3 variables. And then the x to the, now look at the powers. 0, 2, 4, 6. Is there a pattern to that? Yeah, it's common difference 2. So 2n adjust. Minus 2 and there you, so this is your sigma notation for it. So if you want to find the 100th term, just plug in 100. Yeah. Probably on the test I'm going to make you write it sigma notation, but that's better. I mean, it's the same thing, right? So again, the triangular numbers come up, people. How many times do they have to come up before you finally going to realize, I think I should memorize that? It's like, how many times did your history teacher ask you, what's the capital of Montana? Helena, right? How many times are you gonna hear that before you memorize it? Helena, Montana. Hello? You guys don't know the capitals of all the states?
presidents either.
Yeah, I heard there was a test on it.
Oh, that's AP.
See, again, that's exactly why we have problems. You only want to do stuff for your class. What about just for learning?
Oh, I learned it in 2nd grade, but then when we did our 2nd grade play, like we had to name all the
In fact, isn't there a ruler? Is there a ruler, right, that has like all the presidents on it? I have that ruler at home.
I remember when I had to name all the presidents.
Okay, are you sure you don't want to ask questions now? Because look, it's going to be on the video, people. Then you can look back on it. Okay, here, I'll tell you which ones you want to see. Okay, what about like B or C? 3B or C? No? People, we got 20 more minutes, people.
3C.
But not B. Everybody got B. That's what I'm saying. Why not just write 911 on the board? 3B. Sigma n equals 0 to infinity. 0 to infinity. We got cosine n pi.
With 2n plus 1.
2n plus 1. Okay, now on the test, I'm going to give you a hint because I'm sensing pain on this test, you guys. Hint, this is a power series. Or use power series. Okay, so what should you do? Write out the first few terms. Write out the first few terms. Hey, read it off your paper. Say? What are you doing? Playing games?
No.
Then how come you change it? Shouldn't you have the thing up there already? That's why the thing is up, huh? So I can't see it.
I didn't do this wrong.
So how come it's not written out there then? Okay, can you at least just plug in 0, 1, 2, 3 form for me? Go. 0. No, we're plugging in 0. We're plugging in 0. See, you start with
0.
No. Cosine of 0 is 1 over 0 plus 1. 1. Okay, now plug in 1.
Negative 1 over 3.
Now 2. You have to spell it out, plug in 2.
Negative 1.
No, cosine of 2 pi is 1. Positive 1.
Plus 1 over 5.
Anyway, can you, there's like a pattern, man.
1 over 7.
Okay. So you write out the first 4 terms, and hey, you want power series. In fact, this was on the last quiz. What is the only power series that has the odd numbers in the denominator? Tan inverse box, which is box minus box cubed over 3 plus box over 5 to the 5 minus box to the 7 over 7 plus dot dot dot. What number do I have to put in the box to get these numbers here? 1. So that's why the answer is tan inverse 1, which can be simplified to pi over 4. So if this was the exact same problem from the last quiz, that's why it didn't need to be on the board, yeah?
Yeah. Yes. Yeah. We just looked at our quiz.
You're right.
That was on the quiz.
C. Sigma n equal 1 to infinity 1 over 2n. Now the first thing, can I take this 1/2 and put it out here? Yeah, anytime you have a constant, you can put it on the outside. Now, look at this. Hey, you somebody. You somebody. Okay, let's write it out. Some of you go, what? If you don't know anything, write it out. Plug in 1, 2, 3, 4. 1 plus a half plus a third plus a fourth, and it goes on forever. Hey, that's the thing we talked about yesterday. That's the harmonic series. What did we learn about the harmonic series? It diverges to infinity. Oh, so we're going to actually know that, this part. Oh. So this is an infinite sum. So what's 1/2 of an infinite sum? 500,000. No, it's an infinite sum. So it diverges to infinity. Half of an infinite sum, 500,000. Wow. You guys are just... Okay, I saw another problem on there that I think we should discuss. What about the Leibniz's theorem ones? Does everybody understand the Leibniz's theorem? Mioka? I'm talking about problems 4 and 5. Do you understand it?
Yeah.
Saito? Okay, let's do one of them. Okay, let's do number 5. How many terms are needed to approximate sine of 1/2 so that the magnitude of error is less than 10 to the negative 4? Okay, that sounds like the quiz. Okay, so what's the power series for sine box? Sine box is equal to box minus box cube over 3 factorial plus box to the 5 over 5 factorial minus box to the 7 over 7 factorial plus dot dot dot. So if you want to find sine of 0.5, 1/2, what number do I put in the box? Who said box? Okay, now, we are looking for the first term that is less than 1 over 10,000. Okay, so that's 8 times 6. That's 48. Is that less than 1 over 10,000? No. Okay, so 32 times 120. So 32, so no, just do this in my head. Try it! See, now I lost my train of thought. What did I just say? 32 times 12. So that's like 32 times 10 plus 2. So that's 320 plus 64, 384 with a 0. So this is 1 over 3840, is that correct?
Yes.
Are you my mother?
No.
No. So you go to the next one. So that's 128 times 5,040. That's clearly bigger than 10,000, right?
Yeah.
128. Okay, I'm just gonna do it. I'm just gonna do it. 2, 3, 4, 0, 8, 0, 1, 0, 5, 0, 4, 2, 1, 5, 4, 6, and 0. 1 over 645,120. Are you my mother?
Yeah.
Yes, that is way less than 1 over 10,000. So that means add everything that comes before it. The answer is 3 terms, right? Please read the directions, because somebody in period 6, instead of just telling me how many terms, they actually added those terms together. And they wasted a lot of time. I don't want to mention any names, Tang. Read the directions. If I ask how many terms, just tell me how many terms you need. Now, did I even tell you why this works?
Yeah.
No, I didn't. Okay, explain to me then. Why is it that when you have an alternating series, that you will be within the first unused term of the actual answer?
Well, I remember you told us, but I think it's on the video.
No, it's not, because I never told you.
Never mind.
Okay, let me explain to you how it works. First of all, you only can use Leibniz's theorem when it's an alternating series, like this, yeah? 1 minus a half plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus dot dot dot, right? In fact, what is this equal to? Okay, on the test. Hint, this is a power series. Okay, very good. Natural log 2. Some of you going, what? What's the only power series that has the consecutive numbers in the denominator? Natural log 1 plus x, right? Alright, 1 plus box then for you guys, for your movie. Box minus box squared over 2 plus box cubed over 3 minus box to the 4 over 4 plus dot dot dot. What number do I have to put in the box to get these numbers? 1. So if you put in 1 there, isn't that natural log 2? So if you keep on adding these numbers forever, you will get exactly natural log 2, which is approximately 0.693, I keep telling you guys. Those of you going on to AP chemistry next year, that's a number you gotta, Mrs. Fujinaka's gonna tell you, it's gotta be in your brain, man. Okay, now, here's 0, and here's 1. Let us plot the partial sums, okay? What's the sum of the first term? 1, so here. What's the sum of the first 2 terms? So basically then you, from here, you subtract a half and you're here now, right? Now natural log 2 is like 0.693, it's going to be like somewhere over there, yeah? Okay, now what happens when you add 1/3 to this?
Right, goes.
Yeah, you add 1/3, then you subtract 1/4. Then you add 1/5, then you subtract 1/6. What's happening? Yeah, it's going back and forth across the actual value, right? So why is it then, okay, so the sum of the first term, 2, 3, 4, 5, 6. So why is it that if here's the sum of the first 6 terms, why will I be within 1/7 of the actual answer then, the first term you didn't use? Because when you add 1/7, you're going to jump over to the other side, right? But your error, the actual error is this, but then you're within that of the actual answer, right? And that's why Leibniz's theorem works. But that's why it has to be alternating, so you keep jumping back and forth across the actual answer. And that's why the thing works. Okay, and then one more then. Let's do one more. How are you guys doing your long division okay, number 6? Because I can guarantee you you're going to do long division on the test. You guys don't practice though, it's going to be very painful. And what about arc-his theta? You guys got that down? That's the one, E. Everybody got down? Okay, let's do that one. Okay, read me the problem. Saito. Sigma n equal 1 to and what was it 1/2 plus √3 over 2I to the n? Okay, the first thing you gotta figure out is how many will cancel out to 0. Once you find that pattern, it's easy. So you change this to n equal 1 to infinity arc-his theta. So come on, let's do this in our head. If I go 1/2 to the right and √3 over 2 up, how far from Oregon am I?
1.
Okay, maybe we didn't draw it. If I go 1/2 to the right and √3 over 2 up, how far from Oregon am I? 1, and what's that angle? Pi over 3, okay. So, if you plug in 1, you're going to get 1 kiss pi over 3. If you plug in 2, you get 1 kiss 2 pi over 3. You plug in 3, you get 1 kiss pi. I think you guys see the pattern already, right? Every 60 degrees. So, da-da, 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 da-da. So you can see every 6 will cancel out to 0. Hey, didn't we do this problem? This looks like so familiar. Okay, so we know every 6 cancels out. So if you have 100 terms, what do I do? Divided by 6. So that's 1, 6, 4 remainder, 6, 36, remainder 4. There's 4 left over. So what should I do? Look at the first 4 or the last 4. It doesn't matter if it's the same. So here are the first 4. 1. This is the same problem. 4. But then these two point opposite ways, so they cancel out. So the only two that's left are these two, which is 1 kiss 2 pi over 3 and 1 kiss pi. And then you change it back into the a plus bi form, and then you're done. You don't remember? I've been drawing this picture on the board. Cancel out these two.
That was 8 though, right?
Oh, I think it was the same problem, except that was 1996 on the top.
Yeah.
But then it's the same thing, because at 4 remainder, right? The key is how much remainder there is, right?
Yes.
But it's the same thing. Anyway, you know you guys are gonna get 2013 up here, right? You know that already. Yes? Okay, just thought I'd tell you that. I can put any number up there. You just gotta figure out the remainder. Okay, now we're done. Okay, so tomorrow we discuss Series 7 and we are ready for the test on Monday. Okay, we're done.